Hi, my name's Dave. I work for a company called Underscore. I'm here to talk to you about probably the most mundane topic of the evening, dependency injection. Who has wrestled with dependency injection before? Ah, yes. Okay, brilliant. I might say some stuff that you know. I'm not going to talk about really fancy things, but I had some interesting revelations when I was thinking about dependency injection recently. I thought they might be interesting to share with you. But I'm not here alone. To share these revelations with you. I'm going to use some celebrity help in the form of 80s and 90s metal band Megadeth. Anyone a Megadeth fan in the house? Megadeth fans? Give me the metal sign. Okay, we're all here. Okay, wicked. And the reason is this joke is quite appropriate because when I was sort of thinking about, how do you do dependency injection in Scala, it turns out that there are approximately 99 different ways of doing it. These are the ones that I could think of. This is an option, right? Okay, so I'm not going to talk about all of these because I did this thing of what I always do, is writing out a talk and realising it was an hour long. So I'm actually going to drop all of the interesting ones and talk about the mundane ones. So you've already seen some stuff about free. Greg talked about that earlier. That's great. Implicits, which is actually not on here, and type classes is another great way of doing DI. We're going to talk about some standard techniques. And there's still a lot to choose from here, ways that you can model dependency injection. But hopefully during the course of this talk, I'll show you that actually there are a lot of these bear some striking similarities. It's kind of interesting to me what the similarities are. So let's start with some motivation. What is DI? What are our goals for doing DI? So dependency injection is just one of those fancy terms, right? It's a fancy programming term for building your application from bits and assembling them together. You have a bunch of modules or components, I'm going to try and call them, and they each do a single thing, and then a component relies on another component to do something unrelated. And so we're going to wire our application together from loads of components, but when it comes to unit testing, we want to be able to test components out in isolation. So we want to be able to swap out dependencies or parts, because dependencies is too long for this slide, to do our testing. And as a third goal, because we're all Scala programs, we want to do this at compile time, right? We want to have the compiler check our code and make sure it's safe. Okay, so hopefully we're all on board. Build out some components, swap them out for testing, do it all at compile time. So I'm going to use a little example. Unfortunately, I thought of the Megadeth joke too late. So my example is nothing cool or metal. It's a greeting card service. So you remember those like HTML greeting cards you'd send to like Valentine's Day cards? That's very recently, so that's a topical thing. And we might have a Valentine's Day greeting card service here that would create a greeting card, first of all by loading a template from some template store. Let's say we put them all out on the internet somewhere on S3. And then taking some parameters and the template and passing them into a renderer, like a mustache template renderer or whatever. So our main service with two dependencies. And so here's some code. We've got our template loader, our template renderer, and our greeting service. And I'm not really going to concentrate on what's in these things because that's not interesting if we're talking about dependency injection. We're talking about how we get references to these guys inside here. Now, let's think about writing a test for greeting service here. Oh, also notice that I've hard-coded all the dependencies here. So these are all objects. These are vals. Can't change anything. It's all hardwired. So let's think about writing a test for greeting service. We might write a test like this. We're just going to take some parameters, make some of them, call the greet method, and then check that the HTML we get out is what we want. And of course, the problem with this test is we're using whatever template loader greeting service is depending on whatever this functionality is here. And that's the same as our production code. And if we're loading templates from the internet, our tests immediately depend upon the internet, which is not a good thing. It's slow and it's going to be unreliable. So we want a way of swapping out our template loader, that's the problem component, so that we can make this unit test much faster. So let's look at different implementations of template loader. We can turn it into a trait, subclass it twice. So here we have our S3 template loader, which will get the templates from our S3 template store and do all of that stuff. And then we can use a fake template loader in our tests. So with this, we're actually just going to give it a template, and we're going to say, it doesn't matter what anyone asks you, always return this template. And of course, that means that we can just sort of, it's like a no-op, we can just ignore it in our code. And then all these dependency injection things we're going to look at are ways of basically taking these two references and making them so we can swap them out. Okay? That's basically all it is. All right, so let's go with the first approach. The first approach is, unsurprisingly, why don't we just turn everything into classes and inject things as constructor parameters? That seems sensible, right? Yeah. Yeah? Cool? Okay. So we just turn our greeting service into a class. We've got two constructor parameters here, loader and renderer, and then in our greet method, we just use them. It all seems reasonably fine. Now, when we make this transformation, we go from just having fixed dependencies to having things we can reconfigure. We gain a little bit of technical overhead in that every time I want to use a greeting service, I now have to build it. So when you start doing this kind of stuff, as I'm sure many of you are aware, you start getting things like this, like an app object or a wiring object or a components object, where you're creating the greeting service by creating its dependencies. Okay? So you get a little bit of technical overhead here. In order to run your production app, you need to wire everything together. And you get a little bit of technical overhead in your tests. Because now, in addition to just running the test here, we have to create all the components we want to test. We have some preconditions from our tests. And we can normally actually factor these out into our own little fixtures object or something. So we've said, OK, the price of having reconfigurable dependencies is essentially two things. There's wiring for our production app and wiring for our tests. And we have to have that all over the place. So if you think that's a good price to pay, a good overhead, then Dave Mustaine from Megadeth agrees with you. That's fine. And you're good to go. But there is kind of a gotcha. So how many people use this kind of DI approach in their apps? OK. Are you used to seeing code like this? This is the wiring from one of my apps. So this app is about 20,000 lines of play application. And that is the wiring. That's about 100 lines probably of wiring. So that's 0.5% of my whole code base is wiring, which is kind of pretty crazy if you think about it. Who would be happy having this code in that? It's all right, you can put your hands up if you're not. No, who would be happy having this code in their applications? No. Who wouldn't be happy having this code in their applications? So people are difficult to take a stand. OK, there's too much code here. OK, so every dependency injection framework under the sun is basically just about making this thing shorter, right? So let's reel some of them off, right? Anyone use Guice? Are you also people who are using Play? It's very difficult to answer with a show of hands. I suspect you are, right? So Google Guice. I skipped the Java world. I came to Scala straight from programming crazy functional languages like Lisp. So I'd never seen any of this stuff before, but I've seen Guice through using Play, and it's my only exposure to it. And essentially, the whole point of something like Guice or any other, even the XML-based dependency injection frameworks, is that we're trying to reduce the length of our wiring module, which you can see down the bottom here, just by using like an injector, a Guice injector, that kind of knows how to create certain things automatically. And we can sort of give it hints, so we can say, oh, here's an annotation to say, here's a nice constructor you can call, and here's an annotation to say, when somebody asks for a template loader, give them the S3 version, and so on. But all these annotations are doing is just substituting for code that we would write in the dependencies. And then we create our injector and we ask it for something of a particular type. So give me a greeting service, and it will traverse our dependency graph, those blue boxes we saw earlier, and assemble a greeting service for us. So there's a gotcha with Guice. Well, there's a few gotchas. Can anyone call out a gotcha with Google Guice?
Done at runtime.
It's all done at runtime. Well, that's the big one. So there's a few, right? So it's very Java oriented. So we're dealing with annotations. It doesn't know about implicit parameters. It doesn't know about companion objects and things like this. So it's sort of like you have to have one foot in the Java world. That's like the most metal thing I could do. And the other thing, yeah, it's all done at runtime. And in fact, if you're using Play, it's worth noting that I'm pretty sure Play loads modules as needed. So it loads your controllers as needed. So in that app you saw earlier, I've got a controller that's just used for like dumping things to CSV. So it's used by someone in a back office like once a week. So you can ship this application, and a few days later, it will crash. And so, you know, and that's quite disruptive. So don't do it. Stay in school, kids. Don't use runtime dependency injection. So if Google Juice is bad because it's runtime, can we do things at compile time? Have we got something which will do the equivalent of what Juice is doing at compile time? The only example I know of this is a thing called MacWire. Has anyone used MacWire? Okay, cool, all right, a bunch of hands, that's good. So this is it's short for macro wire. It's a library by a guy called Adam Varsky, who's from Software Mill. And what this thing does, well, it does a bunch of things, but at the core it does one thing. It gives you, here's our wiring again, where it's just importing everything from MacWire, and it gives you this wire macro. So the wire macro, you just say wire and give it a type, and it will attempt to create a sort of a constructor call for that type. So here we say, okay, I want an S3 template loader, please, and it will just create. It says, oh, S3 template loader has like a constructor that takes no parameters. Okay, well, I can just expand. I can make that constructor call, and it expands into that constructor call. The same for renderer, and then here. It's going to look at various ways of creating greeting service. It goes, oh, well, if I had a template loader in scope and I had a template renderer in scope, then I could call this constructor, and of course it expands into that constructor. So it's a little bit like implicit resolution there, but it's not. It's like a separate thing. It scans through your local scope for you. And so it's kind of cool, I think, because really it's doing very little. There is more to MacWire than this, but at its core, it's doing very little. If you look at that same application we had earlier, this is now what the dependency injection looks like with MacWire. So you can see, okay, look, there's still 100 lines in there because it doesn't let you skip things, but none of the constructors are reaching the right-hand side of the slide now. So I see this as a net win. Like it's much less verbose. I don't know. Your mileage may vary, right? So this, I can use this and it's cool, but I can live without it as well. Like I'm happy to be in both camps. Okay, and that's MacWire. So that's three approaches to dependency injection so far, and basically they're all the same thing. But there's a few gotchas. Okay, I'm going to do this as a quiz. So gotchas for these techniques of dependency injection, right? So I'm going to put up some code and you're going to tell me what goes wrong with it. Are you ready? Okay, gotcha number one. I've got my wiring here. I have three components, sorry. Foo, bar, and baz. Foo depends on bar and baz. And I'm going to wire everything together and I'm going to try and get hold of foo. What happens? I can't hear you. Null pointer exception. Who thinks null pointer exception? Okay, hold that thought. What happens is nothing. It's all cool. There's no bug. It's fine. Why is there no bug? Because we haven't used the null references yet. So to be clear for anyone who's new enough to Scala, when we build objects and classes, this whole body of this thing is a constructor. And constructors execute top to bottom, right? So the first thing we do when we build app is we say, oh, foo is going to be a new foo. Great, it's going to have bar and baz in it. Well, what are bar and baz? They're null. Oh, whatever, those are values. I'll pass them in. And they get stored inside foo as nulls, and then we go and initialize these things to really what we want. So this is like a race condition. But at the moment, everything is fine until you do anything that uses bar or baz, and then you get a null pointer exception. And you get a null pointer exception, the stack trace for which is probably pointing over there somewhere, right? It's nothing to do with this wiring code. And who's hit problems like this in Scala? Come on, give me a show of hands here. Right, yeah, initialization order problems, they're completely baffling. And they're really annoying. So it's worth noting that forward references like this are dangerous, and if you can avoid them, you should. But if you can't, you can mark all your vals as lazy vals. And that means that when we create this object, when we actually instantiate this object, we're not actually going to call any of these constructors. We're just going to call them when the variables are first referenced. So when we access foo here, it will construct foo, which will construct bar and baz at the right time. Okay? Okay, gotcha two. I've got two modules, foo and bar. Foo depends on bar and bar depends on foo. Okay? This is like one of those university programming problems. Or like if a train is approaching a station. They're both lazy vals. This is cool. I try to access foo. What happens? Deadlock, stack overflow. Hands up for Stack Overflow. Okay, cool. Stack Overflow. Stack Overflow wins. So, okay, we go, oh, I need foo. Okay, I'm going to construct you foo. I'm going to force this lazy val, turn it into a val. I'm going to build a foo. Well, that's going to call this constructor, which needs bar. So I'm going to force this bar, which is going to call this constructor. That needs a foo. Well, this isn't done constructing yet, so I'm going to go and call that constructor, and so on. And we just jump back and forth between the two until we Stack Overflow. And this obviously happens can happen if you have modules with cyclic dependencies in them. So how do we get around this? Any ideas? Sorry, I didn't hear what you said. You said by name, yeah. And that's what we can do. So we can do this little thing here. If you haven't seen this before, this is a by name argument, by name parameter in Scala. That's a lazy parameter, which means that we're not actually going to evaluate the thing that we're passing in until we need it. So it's a bit like a lazy val. So here we create foo, and it's going to say, well, I need to construct a foo, so I'll just pass a lazy reference to bar in. We don't actually construct the thing yet, we just know where to go and look for it the first time someone accesses it. And that's now stable again. Until we do something like this. Because it's really tempting. You've got these by name parameters, you've built these modules. Okay, great. And now I'm going to use these things. So here I've got two vals, and they are basically references to the things either side. So now we're back to now when we construct this thing, we're going to have a by name parameter here. This is lazy. But look, oh no, I need to access it here because I need to assign something to x. And these two things here are going to cause the same cyclic loop. So just the way you use these things in the bodies of your modules can cause problems. And so the only way around this is just don't do this. Like stick these things in methods, because if you put these things into methods, then B will be sort of forced, evaluated when the method is called, which is after you've created your objects. Anyway, this is a nightmare, right? Lazy vals are cool, yeah, blah, 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 blah. Dave Mustaine finds this disturbing. Oh my God. If you think this is a problem, then just do bear in mind that wherever you have cyclic dependencies between modules, you can always refactor them. You just take the bits that are cyclic and put it into a third module. So you can always make your module graph directed and acyclic. But that's something to bear in mind. Okay, right, I am going to run long, but there's some more interesting stuff to say here. So I want to talk, we talked a lot about constructor-based dependency injection and class-based dependency injection. And there's another big style of dependency injection, which is really popular in Scala, which is trait-based dependency injection. Has anyone done trait-based dependency injection in Scala before? A whole bunch of people. Brilliant, I want to interview you each and find out if you liked it. So let's just try some naive dependency injection, a simple thing. Here we have a simple way, we're just composing our app from traits now. So I've turned template loader, template render, and greeting service into 3 different traits. So I've got load method, render method, and then here I've got this thing called a self type, which basically says when I create a concrete instantiation of greeting service, when I actually turn it into an object, I need to mix in something of this type and something of this type. And because I said this, the compiler is happy for us to like say, oh, well, there's going to be a render method here eventually and a load method here eventually, so that's all fine. And then we build our app. I've got some slight naming inconsistencies here, but we build our app basically by mixing greeting service with the things it's depending on. And that's cool, right? That works. Everything comes into scope, it's all available, and it all compiles, and we can run the thing. But there's a problem with this. One of the 3 great problems of computer science, naming things. Okay, now, to illustrate this, I'm just going to no-sell that and move on. To illustrate this, did you notice that I have renamed these methods since I showed you the first slide? In the first slide I showed you, they were called apply, both of them. If I name them back again, check out the code at the bottom. Right, so we call apply on ID and it gets us a template. We call apply on the template and the parameters, it gets us a string. These things are coming from completely different places. They do completely different things. They're called the same thing. And this is the kind of problem we can get with direct trait-based sort of DI or inheritance. So this is kind of a reasonable approach for small groups of modules that we're putting together. But application-wide, we quickly get naming conflicts and we run out of names. Okay, and things called value cause problems, right? You've got 2 things called value and they've got different types, or context, or executor, or logger. Logger is a great one. So what we need to do is move to the way we solve this is we move to some other patterns where we, instead of mixing together things directly, we shift the context. It's better to explain with an example. So there's a thing here called the thin cake pattern. Has anyone heard this term before? Thin cake? It's not a very well-known term. So this has come particularly from an Adam Varsky blog post, right? So there's the cake pattern, which we'll get to in just a second, and then this is a sort of a simplified version. And the idea here is we kind of revert back to what we were doing with constructors, right? We're still building modules with constructors, just as we were at the beginning. But instead of wiring them all in one big object, we package each component up in a module, which is why I'm trying to say component and module. So here I have a template loader module. So it's not the template loader, it's a wrapper. And all it says is, I've got this thing called loader, which is the template loader. And then I can instantiate that, I can subtype it to create the S3 template loader module, and I just initialize that loader to a particular type of loader, right? So I've got these sort of shippable components. When it comes to greeting service, we have a greeting service module, which depends upon the template loader and template renderer. And because it's depending upon these two things, it knows that loader is in scope and it knows that renderer is in scope. So we can use them here where we create our real greeting service. So this is sort of beginning to get at what the cake pattern is. You're kind of wrapping things up in these modules, which are sort of like layers of a cake. And then you bake all your layers into a big cake. So you say, well, I'm going to have that module and that module and that module. That brings all the right things into scope. And then they all wire together. And the key difference here is the words we're using, the identifiers we're importing, the naming conflicts are less likely because these names are introduced purely for the point of dependency injection. Like normally we'd have def template loader with a small t is of type template loader with a big T. And we've got something called the same thing as the class. So we don't have any naming conflicts. But here's an interesting thing. We can assemble our app from all these modules. Think about what the expanded body of this object was. Think about, we're calling a constructor in each of these traits. We're doing 3 different sets of construction, one for each module, and then we're ending up with all the modules. Think about what that code would look like if we inlined it all here. It looks like the wiring module from our initial example. It looks like the constructor example. It's just the same code. It's just rather than have it all in one place, we've just split it up through our application. And not only that, we're relying on knowing the order in which different constructors are called in traits when we bake them all together. This sort of extends and with pattern. It's a nightmare. It's not something I've committed to memory. So I think this is kind of almost showing you how this is just, to me, this makes this, why would you do this, right? Why would you split everything up when you can have it all just written down in one place? And I think perhaps this is not really a full pattern, but it's sort of showing you how you can do trait-based dependency injection without doing the full pattern, which is the full cake pattern, which is my last thing. So the only difference really between thin and full cake is when you do full cake, you actually put the definitions of your modules, in your components inside your modules. So you're actually shipping not only, I'm going to have a template loader, but this is what it looks like. You can put things like vals and type aliases and all sorts of other stuff, implicits in here as well. So you can ship many more things than just classes. And then blah, 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 blah. And you mix it all together again. But there's a problem with this, that when you mix all these things together into something called app, actually, what are you mixing? You're mixing a greeting service, and you're mixing a template loader, but they're all defined inside app. So if you have a gotcha here, the only way to access things like template loader is to dig into your application. The only way to really get to them is to actually look inside the object you're building. So that means that, well, so here, what is the type of app.loader? It's app.template loader. It's not template loader. Template loader doesn't exist anymore. It's the template loader from this particular application, which means that you can't mix template loaders from 2 different apps. You can't bake 2 different cakes and have them interoperate because they've got different types. So the only way you can get to template loader is to basically bolt another module onto your thing. So you have this thing which spreads on and on and on. Like in order to access things, you need to keep adding on modules. And that is called, has anyone heard what that's called? The Bakery of Doom, absolutely. Well-known Megadeth album, and the Bakery of Doom. I think this is I think it's a John Pretty term, Bakery of Doom. So, you know, I think I'd like to discount this full cape pattern because it just causes more problems than it's worth. And I think it was popularised because it was originally used for the Scala compiler, but I think even Martin Odersky has kind of said maybe that wasn't such a good idea in retrospect. So there we go, I'm done now. So in summary, so we had a bunch of things at the beginning of this. I initially intended to talk about things like, talk about reader and free and all that, but you know, we discounted a couple. Cake went because it's too complicated, Guice went because it's runtime dependency injection, and we got rid of traits because of the naming problem. Oh, and XML went as well. And then in the others, I hope I've kind of shown you that all of these things that we covered, we had, okay, no, that's right. All of these things we covered, different types of trait-based and constructor-based, they're all the same thing, right? We covered juice and it's not there, and we covered full cake and it's not there, but they're really kind of all the same thing. So it doesn't really matter what technique you use. I would personally just go back to constructors because it's the simplest thing, it's the easiest to understand. And we didn't talk about functions and readers and all that kind of stuff, but you can compose functions together. We didn't talk about free, but Greg did a great job of showing you how you can swap interpreters for testing and not testing, so that's really where you're doing your DI there. And that's really the whole thing. So really, this is all the same stuff. Okay, I'm going to get out of here, but there's some shameless plugs. I've got some more thoughts about readers and stuff like that. I'm going to try and write a couple of blog posts over the next couple of weeks. So watch_.io/blog for those. And if I don't blog them, hassle me, tweet me or something. I wrote a book. It's a free book. You can get it from our website. So it's _.io/books. It's a book about Shapeless. It's a good, fun, enlightening read about something quite difficult to get your head around. We also have other books. They all cost money, but there's a 50% discount, which I haven't managed to create yet today, but I will by the time I hit the pub, SC Feb 17. And we're doing a course on cats in a couple of months' time. So if you're interested in doing a public course on cats, that's the sign-up place. Got some references. These will be the slides online. Thank you very much.